flow together like an ocean, every low and every high. And I would have you in me, baby, any way your heart could bear. Even if you had to leave me, I'd always be waiting here. Even when we are apart, I will keep you in my heart, and I wouldn't change a thing, even if I were the king. I've never known a brighter sunset, but every day I see it bright. I never thought it could be better till I saw it in your eyes. Even when we are apart, I will keep you in my heart. I will hold the world at bay just to see you smile again. And when time begins to fade, I will love you just the same, and I wouldn't change a thing, even if I were the king.
Hello, hello. How are we doing? I'm not eating anything. Who's Stormzy? All right. So, did everyone get this printed yet? I mean, if you don't have a printer, you don't have to print it, but if you have one, you should print it. Also, did you guys add the Google Classroom onto your Google Classroom? the email I sent out earlier today, I believe, because some of you having trouble with, well, a lot of you having trouble with turning in stuff from School Loop, so I figured that we should just turn in from Google Classroom, because that is a convenient way to upload photos of your work, etc. Right? So yeah, so that's why I'm doing that. Okay, so if you haven't signed up for Google Classroom, you should see my email and try to sign it up. Yeah, that's fine. I haven't taken attendance yet. So, are we ready? Can we start now? Alright. So, today we're going to be talking about sequence in the series. This is going to be the last chapter of the year because, you know, the whole situation. So, at least until further notice, we're pretty much trying to finish this up, as this will be an important topic for calculus as well. So there's that. Okay, so here we go. So sequences are basically very simple definition. Okay, what is sequence? Sequence is basically a list of numbers. Okay, a list of numbers. These definitions are very important because later on we're going to have a series. Series is the sum of sequence. Okay, so make sure that whenever you're addressing addressing these things, you know what you're talking about. Okay, so sequence is just a list of numbers. It doesn't have to have pattern. Okay, it can just be a random sequence with no pattern. But obviously, we are more interested in things that with pattern, because if there's no pattern, then there's no point of talking about it, right? So here we go. Let's talk about these sequence real quick. So if you look at this is 1, 2, 3, 4, right? So what would be the 10th term then? 10th term is term number 3, right? So 1, 2, 3, 4. It seems natural that your 10th term would be T10 will be 10, right? And T50 would be 50. This subscript means what the term number is, okay? And this indicates the actual term, okay? So we will call this like term 1, term 2, okay? Sometimes we use A1, A2 as well, or different types of notation. Depends on like what book you're using or what meaning it conveys underneath, okay? We're going to talk about that in a bit. So nth term would be what? Tn would be equal to, what would it be? If I want to find the nth term, this is a time when you just type and answer me. Yeah. N. Thank you. Okay. So this looks very easy, but this is the fundamental of all the things that we'll be doing. Is try to come up with some sort of formula, explicit formula for this sequence. Okay. So number 2. 2, 4, 6, 8. Similarly, the 10th term would be, you're going by 2s, right? So 2, 4, 6, 8, 10, blah, 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 all the way to 10 seems to give you, what, 20, right? Because that's how it goes. Number 2. T50 would be 100. So Tn will be what then? Well, it's multiplying by 2, so we should call it 2n. Okay? And that should work for any sequence, any term. Okay? That's called a general explicit formula. Okay, so explicit formula. Okay, explicit means everything is defined explicitly. Okay? So, let's look at these two then. 10, 17, 24. What is this doing? What is this doing? So 10 to 17 as well, and 17 to 24, you're increasing by 7. This is called linear, right? Linear equation, linear growth. Plus 7 plus 7. Yeah, Ted. So the worksheet that you have is available in the resource file that I attached an email. No, I didn't attach it, but in the email I told you where to go on Sunday night, I think. It was the email about you can now print blah 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 packet. I think sequence and series packet in it's in the email, and it tells you where to go to get it as well. It's always been there, but I recently changed it, so make sure that you have it. So if you don't have it, you should print it. If you can't print it, then you should follow along with the PDF version, okay? Or you can just follow the screen. That's fine too. Does that make sense? All right, so you're plus 7 each time. So since you're always adding 7, you kind of want to have some sort of, so it goes like this, okay? So you start with 10, right? To get to, this is the first term, okay, T1. To get to T2, wouldn't that be T1 plus 7? Would you agree? T2 is T1 plus 7? Because you're adding 7 each time, right? Then T3 is T2 plus 7, right? T2 plus 7? Do you agree? T2 plus 7? But isn't T2 like T1 plus 7? So if I substitute that part, wouldn't that be T1 plus 7 plus 7? So how many 7s am I adding now? T1 plus 2 times 7, right? There are 2 of them. Am I still making sense? Then naturally T4 would be T1 plus 3 7s. Would you agree? So you're basically starting with 10, so your formula Tn should be 10, which is the first term, plus 7, but 7 many times. How many times exactly? Is it the same as the term number? Observe. How does the pattern go? Sorry, not this one. T3 versus 2, 2 versus 1, 4 versus 3. So how does the term number versus how many sevens do you add? So this is 4, then you add 3 sevens from the first term, right? Because you start with this, right? Add 1, add 2, add 3. So it's exactly, anybody want to type this in? So the number of sevens you add to the first term relative to n should be n minus 1. Okay? All right. Similarly, very good. Similarly, let's look at this. Obviously, you can multiply this out. Okay, you can multiply this out and simplify it, but we'll leave it like this because for a good purpose. Okay. So look at this. Next part is then start with 37. What is it doing? What is this? Subtracting 8. So you're minusing 8 each time. So looking at this, you're subtracting 8 a number of times, right? So here, it's then natural to think, okay, well, if I start with 37, so Tn, if I start with 37, here I added 7, right? Many times. Here I'm going to subtract 8. Then similar to the n minus 1 part, because to get to the next term, you add 1 7, right? So get to the second term, you add 1 7. Get to the third term, you add 2 7s. Similarly, you're going to do the subtraction here, n minus 1 times. Okay? Does that make sense? Are you still okay? Okay. Alright, so that brings out one important thing. So you see how these two are all adding or subtracting by the same amount? So in math, we have this adding and subtracting sequence, a specific name called arithmetic sequence. Arithmetic sequence. Not arithmetics, that's noun. This is adjective, adj dot. Yeah, that's your arithmetic sequence. So goes like this. We use a because it's arithmetic, right? an equals a1 plus m minus 1d. What is d? D is the difference, common difference, which is what you're gonna be adding or subtracting. If it's adding, then it's positive. If it's minus, it's negative. Okay? Oops, let me move it over here. How are we doing? If you're okay, let's look at the bottom two questions. Number 1. All right, I'll give you some time for this. And while you're doing this, let me take attendance real quick. If you are here, type here. Wait. I count 27 people. Yeah, I see that. I'm trying to map everybody. Is Sahana here? Sahana is not here. All right, we're good. Wait. Oh, Karen was here, right? Okay. All right. So, let's look at these problems. Oh, thanks, Karen. All right. So, let's look at this one first. So they say find nth term of sequence, find the equation of the line. So, yeah. So the nth term, because this is a plus 3, so automatically, right, this will be a, this will be a plus 3 arithmetic sequence. So difference is 3. So when you're doing the nth term, it would be, what, 2, let me write an first. An equals 2 plus n minus 1d. So it's what? N minus 1 times 2? 3? 3. Because 3 is the common difference, right? It's how many? 1 less than the number of terms. Okay? And to find the equation of a line, you simply just simplify this. Why? Because this is your result, right? You can simply write as this. Y equals 2 plus x minus 1 times 3. Kind of like this. Why can I do this? Because adding the same amount is equivalent to adding 3 to y every time you move up x, right? Because your x is your term number, right? So if you start 1, 2, 3, 4, and you put plus 3, plus 3, plus 3, like this, 1, 3, 1, 3, 1, 3. Isn't that equivalent of the same slope all throughout? So you can form a line here, okay? So here, so it makes sense that your slope is 3, and you have a point, right? 2, 1. So, or 1, 2. So then you can simplify, obviously. So be 3x minus 3 plus minus 1. Okay, 3x minus 1. Does that make sense? Your output is number of terms, your y value. Sorry, not number of terms. The actual term is your y. X is number of term. The index of term. Okay. All right. So let's look at this. So which term is 259? First of all, let's represent this with a equation first. So an equals 7 plus what? M minus 1. What's the difference? You add 6 each time, so plus times 6. And this, you want it, because you don't know what number of term it is, so you want to set it equal to 259, because that's what your answer wants to be, right? And then you literally just solve for this. Okay, so what I'm getting is 7 plus 6n minus 6 is equal to 259. So what's this, plus 1? So 6n equals to 258. Right, so n is 43. So 43rd term of the sequence. So you keep counting 7, 13, 19, all the way. This is the third term only, right? You keep going to 43, then you will get 258. Okay, the 43rd term will be 258. Are we okay? So that's the case. Let's look at this next one. Okay, next page. Is the following sequence following a linear pattern? How would you know? Is it linear? Is it linear? How would you know? Type. Is it linear? No common difference. What is the difference here? Okay, well, if you look at it, it'll be plus, plus 1, plus 2, plus 4. Obviously not adding the same thing, so it's no. Because common difference, no common difference. Okay? I like that. You're not adding or subtracting the same thing. Okay? But what are you doing here? What instead are you doing? Can you find the pattern? What instead is happening here? Multiplying by 2. Multiplying by 2 times 2 times 2 times 2, right? If it's multiplying by 2, so remember when you were doing arithmetic, you were trying to do an equals a1 plus n minus 1 differences, right? So here we're trying to replicate the same exact thing, okay? So to do that, let's use G, okay? Because this kind of terms is called geometric sequence when you multiply, okay? So Gn, so instead of adding, you're multiplying, correct? So in this case, you're multiplying, so multiplying with the first term is 1, right? Times, what are you multiplying by? 2, right? You're multiplying by 2. How many times? Same thing as how you added the difference n minus 1 times. Here you're multiplying by 2 n minus 1 times. But when you multiply, where do you put that multiplication number? Isn't it multiplied by yourself? So it has to go here in the exponent. Okay? So this would be the formula here. Okay? And in general, if you want to use geometric, it's always going to be the first term, G1, times r to the n minus 1. Here, the r stands for ratio. Okay, common ratio. Has to be the same number in order for it to be geometric. Okay. All right, common ratio. So it's very similar to arithmetic, but you change it to geometric by multiplying instead of adding. Okay. How are we doing? Try these two real quick. Try these two. Got it? All right, here we go. So let's take a look. So 2, 6, 18, 54, that's times 3, right? So very easy. Be 2 times 3 to the m minus 1. Okay. First term is 2. Ratio is 3 to the m minus 1. Okay. All right. This one, multiply by 4, right? Times 4. So it'll be 5 times 4 to the m minus 1. Okay, it will work. Okay, so these are called, once again, geometric sequence. Okay, all right. So, that's that. So for a little bit of housekeeping while you guys do the practice is that, as I said, Google Classroom has been moved. The turning in assignment has been moved to Google Classroom, and your homework, I already posted the first one on, although I'm going to change it a little bit because it seems a little bit too much, maybe. So I'm trying to not give you guys too much to do because some of you are still scrambling to do some of the work. It's okay. So this week we're just gonna do page 1 to 3 of this packet and an attached worksheet that is on the assignment itself. Right now I see 23 people in it. So there's a extra sequence worksheet in the copy, in the assignment, so you can look at how it works there. And that pretty much will be your homework plus classwork. Any questions you guys might have to start your work? Do I need to reiterate some of the things? Or is it pretty clear how it goes? So the homework assignment is still due Friday, and you just turn it in from there because Google Classroom is really easy to upload photos, so you should be fine. Yeah. Or you don't even have to print it out if you don't want to for that worksheet because it's too small to do on. So you can just do your work on a sheet of paper based on the worksheet and then just take a picture of the photos. Does that make sense? Because there's worksheets they're too small to write work on. Some of them might be able to, but some of them might be harder. Okay. But this week should be a relatively light week for your workload, I hope. So you're just doing this page, the following page, and the worksheet. Okay, the general sequence part, which is the following page, I need to talk about before you can do it because it's a little bit more complicated. Okay. Any concerns? If you haven't signed up for Google Classroom, go read my email and sign up there. Okay. So, do you need me to go over immediate questions here? So that or you can wait for an office hour too if you want. It's up to you. Sorry, that was too loud. If there's no further questions, can we do the worksheet in our packet? How are you gonna do the worksheet in your packet? Like find a room in there? How do you plan on doing that? I don't understand. We're not learning matrices this year. And 3D graphing, I don't think this, unless we have time after this, this is going to be the last chapter. Okay. No polar coordinates. Not doing that. You don't need polar coordinates for Calc AB anyway. Right? So no polars. Regular doesn't do polar. No. What? HU WAD? You WAD? What? What is this? So, in the packet, this is also written on the Google Classroom as well, and on your assignment. It's basically the first 3 pages, all right? So the rest of this page, plus the next page, plus the worksheet I attached with your assignment on Google Classroom. Okay, so it's in the description, it has a due date and everything, so 4 pages, basically. But you already did 1.5 page with me. Make sense? Yeah. All right. Any other concerns, questions? No? Time to say goodbye already? What are you guys doing the second week? Same thing you did first week? Is it still fun or is it boring now? Mr. Lee, go to Google Classroom and look at the assignment. Everything is there. Oh my god, Sayun. It's the first 3 pages, all right? This page, and then the packet, not packet, the homework worksheet I attached onto the assignment. Just go to the assignment and then read there, okay? No, it's okay. It's just, Next time somebody asks the same question, I'll just let them drag back the live stream. So you unlive yourself, right? So you get your info via replay. Anything else? No problem. Okay. Well, you know where to find me. You can hit me on Remind. You can hit me on email. If you have any questions you want me to go over in the office hour, just shoot me an email or Remind, then I'll talk about it in office hour the next day, most likely. Or the day, if the office hour hasn't ended yet, maybe. Okay? If there's no other questions, I will turn off the stream here. Yeah? Goodbye? Goodbye? I'll show my hands because I didn't put up my gears and camera look. So can't be on camera. Goodbye.